In this video, we're going to use properties of radicals in order to simplify expressions that contain radicals. So there are two main properties of radicals that we need to be aware of. The first is the product property or the multiplication property of radicals. And what's really interesting about radicals is if we have, say, two radicals where we are multiplying them together and they have the same root. If they have the same root and we are multiplying those radicals together, we can actually turn it into one root, multiply the a and b values together, and keep them under that same radical of n. Now you can flip it either way. You can either break it up and then split it up into two multiplications, or you can take two multiplications and turn it into one radical, which I personally think is kind of cool. Now, the quotient property works in the same way. If you have a big fraction here with one radical on the outside, you can split it up into two little radicals with the a in the numerator and the b in the denominator, and you can solve each radical separately. What's equally cool is we can take those two radicals here. Say we had a division problem and we noticed they had the same root. If they have the same root, we can actually combine them into a singular fraction underneath one radical with that same root. So we can kind of use this to our advantage, working in both directions, depending on what we need to simplify down this radical. So let's work through three different examples together. This first one, I noticed that I have multiplication between two radicals with the same root. And right now, neither one of those really simplifies down to anything that's nice. So I'm going to try to use the product property of radicals here to see if it'll simplify in a different way. So since it has the third root, I have to put the third root on the outside because they both have the third root. And then I have 12 times 18. And I can put that all underneath one root. Now remember, this only works if they have the same root. If this was a 2 and this was a 4, this would not work because they need to be the same. Now if you don't know what 12 times 18 is, that's okay. I'll help you out in this video. 12 times 18 is 216. So now we're going to start thinking and see, okay, is the third root of 216 something nice? And if I start thinking through, I know it's not 1 because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. But if I work out 6 cubed, 6 times 6 is 36, and 36 times 6 is 216. So in this case, I get an answer of 6. So just by rewriting this using the product property of radicals, I was able to actually solve this and get an actual answer. So it's a really helpful property. Here I can see that I have the quotient property or the division property of radicals. And because they both contain a root of 4, I can turn this into one large fraction of 80 over 5. Now if I evaluate that fraction, so this is still the fourth root, 80 over 5 becomes 16. And I know that I can take the fourth root of 16 because the fourth root of 16, if we have 2 times 2 times 2 times 2, 2 times itself 4 times results in 16. So this would become just an answer of 2. Now if we look at this third example here, you'll notice that there's not a number in the root, but remember when there's not a number in the root that these are really implied square roots. And again, we have this quotient property of radicals here. So because both of these radicals have the same root of 2, they can be combined into 1, so it's the square root of 63 over 7. And then I know that 63 over 7 can be simplified to be 9. So this is the square root of 9. And we know that the square root of 9 is 3 because 3 times 3 is equal to 9.